half wave rectifier with filter. So when this word filter came, one can correlate with number of the applications in our house also we are using, where we find the filter. So now what the filter actually doing here with half wave rectifier? So first of all, we should be knowing that if we use this rectifier circuit, which we are calling as a half wave rectifier, we get the output like this. This is the input waveform, this is the output, and here we know during the positive half cycle only we are getting the output, during negative half cycle we don't get it. So this is the term we all have covered. Now if we recall the definition of the rectifier, we know that we have defined the rectifier as like a rectifier is a circuit which converts AC into DC. But when we look to this waveform, we can say that this is not the DC. This waveform is called as pulsating DC, but this is not the pure DC. So it means that there is a further chance of improvement in the output. So we can have the conclusion which I have written here to save the time. So here we can read this, that the output of the rectifier is not pure DC, it is pulsating DC. Why pulsating DC? Because here you can see this is in the form of pulses. So it is can be called as the AC mixed with DC, because this is not AC, right? It is not AC, it is not crossing the zero line. So we cannot call it as a complete AC, but also it is not pure DC. So we can say that it is a mixture of AC and DC. It is called as pulsating DC. The unwanted AC present in the DC output of the rectifier, it is also called as ripple, R-I-P-P-L-E. So what is ripple? Ripple is nothing but the unwanted AC which is present in the DC output of the rectifier. And to remove this ripple, we use the filter. So I hope this thing is clear, that why we are using the filter. So this can be represented in terms of block also. So this is the rectifier where AC is the input and we were expecting the output which is pure DC, but we get the pulsating DC, and that's why we have connected a filter, and after connecting the filter we have got this output which is a pure DC. Now you can have the comparison. This is the actual output of rectifier which we have studied up till now, and we are expecting this type of pure DC. So to obtain this pure DC, we need to use the filter. So this is the filter. So actually if you see what is filter, it is nothing but a simple capacitor. It can be a capacitor or a inductor. Here we are interested to use the capacitor as a filter. So from this diagram you can see what we are doing. We are simply connecting a capacitor at the output of filter at the output of the rectifier. So in this way, here also if I draw a capacitor in parallel with the load, so this capacitor is nothing but the filter, right? So this capacitor can be connected on this side or in this side also, right? So no problem at all. So if this is the circuit, this is called as the half wave rectifier with filter, right? Now let us understand the working of this. We know that when the diode is when the potential at this point, let us say this is point A and this is point B, right? So when the potential at point A is more, diode will be forward bias. When the potential at point B is more, diode will be reverse bias. With this simple concept, we will proceed. So first of all, whenever the positive half cycle is coming, we can see directly we'll switch to this, because this output we are getting at the output of rectifier. So we'll start from this point, from point 0. The output voltage is increasing and it will rise to its maximum value. Let us say this is the maximum value called as VP, right? So from 0 to this point, the voltage is increasing, right? So in this case, initially there is no voltage across the capacitor. That's why the diode is forward biased, and it will make it will act as a closed switch here. So during forward bias, the diode is acting as a closed switch. Hence, it will allow the current to flow through this, and it will flow through the load resistance. But here the new thing is that we have now connected the capacitor. So what will happen? The capacitor will start charging. Ultimately, what I want to say is, during the positive half cycle, from this to this portion, the capacitor will start charging, right? Up to what potential it can charge? It can charge maximum up to Vp. This is the maximum voltage which we get normally. Now after this, the output starts decreasing, right? Now if it starts decreasing, what will happen? The voltage across capacitor will start, means the capacitor will start discharging. Now due to this, what happens? The potential at point B becomes more, because the potential at point B, whenever I am saying, it is the potential here, right? So after this point, what happens? The potential available across the capacitor becomes more as compared to the potential at point A, because this is the potential at A, and here we can see after charging of the capacitor completely, the voltage starts reducing. So in this situation, what happens? The potential at point B becomes more as compared to potential at point A, and here the diode, which is now acting as a closed switch, is now becoming reverse bias, and whenever it becomes reverse bias, it will act as a open switch. Now we have the scenario that the diode is open because it is reverse bias and the capacitor has the charge which is equal to Vp across it. So now diode will find some path through which it should discharge its potential. Now it cannot discharge through this path because the path is not continue or it is not connected. That's why it will start discharging through this resistor, right? And the capacitor will start discharging, and when it starts discharging, its voltage will go on decreasing, right? But here there is a difference. Capacitor has charge through the diode, and diode, when it is forward bias, it is having very less resistance. That's why it has charge very fastly. But during discharge, it has to discharge through this resistance, and the value of resistance is higher as compared to the resistance of diode, and that's why the time taken by the capacitor to discharge will be more. It totally depends on the value of resistor. More the value of resistance, more will be the time required for the capacitor to discharge through it, and that's why the capacitor will start discharging but very slowly. In this way you can see it is discharging very slowly, and as soon as it reaches to this point, what happens? The next cycle is coming, right? And when this cycle comes, again the same thing repeats, that the diode becomes forward biased, and whenever it becomes forward biased, we know it acts as a closed switch. Due to this, again the capacitor will start charging and the voltage across the capacitor increases. Again it increases up to the point which is equal to this Vp, that is the maximum potential. After charging up to this point, again the same cycle repeats. The diode becomes reverse bias and it acts as an open switch, and after that the capacitor again starts discharging, but it discharges very slowly, and this cycle continuously go on, and in this way finally we get the output across the load resistance which is same as the voltage across the capacitor, and this is like this. So we can have the comparison between the voltage which we got previously and now this. So this is the pulsating DC, and this is the DC which is having lesser value of pulsation. If we change this value of capacitance, there are chances we may get the waveform which is directly very smooth, which will not have any kind of ripples in it. So this is how the capacitor will filter out the unwanted AC signal available at the output of rectifier.